Welcome back. This is still 1.6, so continue to add it to those notes. As you see, the Bell problem is an absolute value equation. Something we did not discuss yesterday was what you do if you have something on the outside of your absolute value. If you notice, it's being multiplied by 2. Some people had questions yesterday about this. No, you can never distribute inside an absolute value. You must get it by itself first. So our first step is to divide both sides by 2. Then we'll have the absolute value of 3x minus 2 equals 7. Now from here, you can write your two equations and solve. I'll let you go ahead and do that. Alright, when you solve these out, you should get x equals negative 5/3 and x equals 3. Like I said, this is still 1.6, but today we're going to be discussing inequalities. So we're going to have that less than or greater than symbol. Just like before when we were graphing absolute value equations, we're still going to be having open or closed dots. If it's and or in between, it's going to be shaded in between. If it's or, it's going to be on the outside. Now, when we are solving absolute value inequalities, we still have to write our two equations. So, again, the first one you write just how you see it without the absolute value signs. So we have 4x plus 5 is greater than 13. Now, for your second equation, you do the same thing. You still rewrite the left-hand side without the absolute value. So you have 4x plus 5. You still make your right-hand side negative, but since we have an inequality symbol, we have to switch that. So it was greater than, now it needs to be less than. So go ahead and solve these out. For our first equation, you should get x greater than 2. And for the second one, we should get x less than negative 9/2. So again, we plot these on our graph. So we have 2. It's greater than, so we shade to the right. And then negative 9/2 is negative 4.5, so plot a point somewhere in between 4 and 5. And it's less than, so we shade to the outside. Notice how we shade to the outside, we didn't shade in the middle. So anytime you start with a greater than symbol, it will be an or inequality, so we shade on the outside. Alright, this next one, putting it all into play, we have a word problem. We have a professional baseball should weigh 5.125 ounces with a tolerance of 0.125. Write and solve an absolute value inequality that describes acceptable weights for a baseball. Now, we have to write an absolute value inequality. We're going to have our absolute value sign. When we're writing this out, we need to come up with some variable, and that will always go first. So since we're talking about weight, I'm going to use W as our variable. And then since W is our weight and what it should weigh is going to go inside our absolute value. So I have 5.125 on the inside here. And then the tolerance will always go on the right-hand side. So we have 0.125. Now we have to determine what way our absolute value goes and what sign goes in the middle here. If I were to put a plus and were to solve these inequalities out, that means we subtract this over, and that means our weight would be negative. So since that does not make sense, this has to be minus, so we'd have to add it to the other side. And since we want acceptable weights, we want our first inequality to start with less than or equal to. So then we solve these out, And when we write this, notice how we start with a less than sign to start with. So that means we can put our variable in the middle, have our two inequality signs. Notice how when we write our variable in the middle, both your inequality signs have to be going the same way, and we read from the inside out. So our weight should be less than 5.25. Again, this is solving them out, writing out your two equations, or two inequalities. Remember, your second one must switch your sign and make this negative. So on the right-hand side, our weight must be greater than or equal to 5. So the acceptable weights for our baseball are between 5 and 5.25. Go ahead and solve these out and then graph the solution. Pause this and come back. For the first one on the left, since it starts with a less than, that means we can put our variable in the middle. Make sure your inequalities are both facing the same way. And when we solve this out, we should get x less than or equal to 4 and x greater than or equal to negative 5. When you solve the one out on the right, again, we start with less than, so we can put our variable in the middle. So this is like an and compound inequality. And we get x less than 4 and x greater than negative 8. When you plug these back in, they do work. Make sure you still graph the solutions. And here is your homework. Come ready for class tomorrow and ready to work on it.